Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Spot.io. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes I'd like to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we'll be sure to send you an email with a link to access the recording on demand. Now, if you'd like to get involved in today's conversation, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, for any specific questions you have for Carl, we'd like you to send those in to the Q&A tab on the right side of that chat section. We've got time set aside at the end of our program to address questions, so be sure to send them into the Q&A, and we'll do our best to answer as many as we can before we close things out. Additionally, we have a couple of polls that we might throw your way, and we've got some handouts that are available for you, so feel free to jump to that handout section and download those while we've got you. Finally, we will be selecting two of our most engaged attendees to win a $50 Amazon gift card. Ways to become eligible are to send in your chats, your questions, and at the end of our program, we will be pushing out a link to our post-webinar survey. It will also be found in the handouts, but all three of those ways will make you eligible for our giveaway. So our topic today is running Kubernetes the smart way in the cloud. I'm joined today by Carl Gridley, Customer Success Engineering Manager at Spot.io. So Carl, thank you so much for joining us today on Techstrong Learning. Would you like to take it away from here?
Thank you so much, Cody. Welcome everyone to my talk. Thank you for coming along to listen about Kubernetes and my thoughts on the smart way to run it. I manage a team of solutions engineers and customer success engineers at Spot across EMEA. I have the good fortune to work with some very good people and many, many great customers. And I can share some of our opinions and thoughts on the way to run this. Here's my agenda for this session. There are a million ways to run Kubernetes in the cloud, and it's an immensely broad topic. And today we have maybe 35, 40 minutes of content to talk about. And what I'll be looking at mostly is performance and the complexity of getting performance right in Kubernetes on an ongoing basis. Mainly from a cost perspective to make sure we're spending the right amount of money, but to do so in a way that's not going to impact application performance or cause us issues. So I'll talk about the challenge to begin with. Why is it so hard to get the performance right? I'll talk about the complexity and run a demo on some of the ways we can help address the complexity of operating a Kubernetes environment. And then finally, I'll talk about the way that we can help automate this kind of environment with a sneak preview at the very end of some cool stuff that we've got coming as well. So why is getting the performance right so difficult in Kubernetes? I kind of just set up an argument there, right? Is it difficult to get it right? It depends on your definition of what's right. So in that we can get things working and not breaking, which makes the engineers like me happy, for sure. And we can do that by over-provisioning, by making sure there's too much performance, over-engineering, if you like, which is not in itself a bad thing. It just carries with it a cost implication. And certainly in Europe and many places around the world, cost is currently top of mind for the IT directors, for the CFOs, CIOs out there. And this priority is being driven down into the businesses. This is a survey that we commissioned, and the top response there was the challenge people face is over-provisioning. I worked in the front line in the field for many years, and pretty much every Kubernetes cluster that we brought on board to our platform was 2 times as big as it needed to be. It was over-provisioned. The workload requests were too high, the guarantees were higher than necessary. And this meant a whole bunch of money was being spent that didn't need to be spent. Other top responses, too many instance types or VM types. Each cloud vendor has around 600 or so now. Google has a clever way of building your own custom instance types. And it can be difficult to decide, is Graviton, is ARM going to be better for me in x86? Is this latest instance family going to be better for this particular workload and reduce my costs by running them faster? Is it task-based, that kind of thing? Pricing models are a challenge. Reserved instance, savings plan, on demand, spot VM, spot instance, CUDs and SUDs. Deciding amongst all these different ways to buy the compute is a challenge, and then understanding how they plug into Kubernetes, it takes that to the next level. Then at number 4, underutilization of resources, which is kind of in the same family as over-provisioning, not using everything that you're paying for. But it's not just us who see this. This isn't a FinOps presentation, but if we switch and take a look at the FinOps practitioner perspective, then the State of FinOps 2024 report calls out reducing waste, reducing unused resources as the top priority this year for FinOps and businesses. That means for those of you in organizations who have a FinOps practice, I'm sure they are already, but they're going to be bringing to you initiatives to reduce waste, to right size will be the most common term, typically at the instance level, but really that should be carried through to the workload level in Kubernetes as well. The data folks over at Datadog see the same thing. And this stat should really hammer it home for folks operating Kubernetes clusters. 65% of containers use less than half of the CPU and memory that you're paying for. This means that most containers have been given twice as much performance as they need. They're costing twice as much money as they should, and people are sitting up and taking notice. This is not the best way to run infrastructure. Now, absolutely, some of those should have twice as much. The critical applications, things you want to over-engineer, for sure. However, most of them will not and should not have that huge buffer of headroom available to them. And we need to make sure that we get all of these right. The Cloud Native Computing Foundation see the same thing. This isn't just for Kubernetes. This is a kind of a general cloud survey. But they absolutely, 70%, the biggest bar, and all of the surveys I've just looked at, see over-provisioning as the main issue, paying for too much in the cloud. And this is especially painful, I think, in the cloud compared to on-premises because you can fix it in the cloud. And if you do fix it, if you fix the over-provisioning, you stop paying too much straight away. Right? There's no real lag time from getting it done. That doesn't mean it's easy to do it, of course. So why do we over-provision? It's not that we don't understand. We know, the folks running Kubernetes clusters know there's too much allocated, more than needs to be. It's pretty straightforward to go into a cloud console and see a bunch of compute VMs not running at 100%, running a lot less. And the reason we don't fix it is because we're concerned about impact on the workloads. As engineers, reliability and performance, as these go together, these are the things that get us called out of bed. If pages were still a thing, these are the things you would get a page about and have to get up and get online at 1 in the morning, go into the office on a Saturday afternoon to get things fixed. Because things cost too much, that's a problem. Engineers care, of course we do. But that's typically a problem that comes up once a quarter when we have a sit down with some finance people, some FinOps people, and they give us some objectives. We talk about spend and money and things like that. Money, the cost of these things is not typically an emergency for us. Performance and reliability are. So we don't want to break things. That's why right sizing is actually really hard to do in a safe way. Hence the second point there, difficulty executing remediation of these resources. That time when we do optimize is a real mix. Continuous, so I would argue that auto scaling in Kubernetes is a form of continuous optimization. It scales up and down the worker nodes, so it's got the right amount of performance at a high level. Otherwise, folks might visit their commitment plans, reserved instances on a monthly basis, more likely a quarterly basis. They might visit instance types kind of annually, as and when they're in the news, maybe when AWS ring up and say, hey, we've got these new cool instances, you should consider using them. It's kind of event driven almost. The third and fourth ones, I feel are very related. So people optimize their Kubernetes estate when leadership requests it, and leadership will often request it when the spend goes past a specific target, which gets you noticed, gets your Kubernetes bill noticed. And then someone says, hey, you should do something about this. So why does it matter in the cloud maybe more than on-premises or in a different way to on-premises? I feel the inherent quality of the cloud is elasticity, using what you need when you need it, and only what you need, and scaling that up and down. And Kubernetes is amazing at this, right? Replica scaling at the pod level, more when you need more workload, scaling down maybe to 0 when you don't. Driving the scale of instances or VMs up and down as the workload scales. But then where this kind of falls over in Kubernetes is getting the workload performance level, right? The requests set correctly. And this is the hard bit to do that we're going to talk about today. And the bit that if you do it wrong, could have those performance reliability issues that we really want to avoid as engineers. But in the cloud, when you get this right, the positive effects will happen straight away. You'll be saving money, from the moment that you turn a resource off, from the moment you're able to scale down. As a corollary, if you need to scale up, that can also happen very, very quickly. Whereas on premises, you're more concerned about getting the performance requests and sizing correct for reliability, for fault tolerance, if you're swapping physical VMs in and out. You're kind of less concerned about the scaling in and out in a broad way because your lead time for a physical server, 1 week, best case, more likely 2 to 6, depending on whichever kind of world crisis is going on at any one time. But in the cloud, we can do this fast. So am I saying don't over provision? No. And maybe I shouldn't say the word over provision either. I probably shouldn't say over engineer. What I'm saying is we should do it in the right places. In the places that we really care about. For example, an airliner has triple redundancy in its control systems because the event of a loss of all of those three would be catastrophic. That's not over engineering, it's appropriate engineering in the right place. And we should do the same with our applications. So our top 20%, the business critical ones, the ones that make you money, the ones that deliver your important services out to the world, ones that keep the lights on, wherever they may be, should be where you spend 80% of your time. And these should be the ones with bigger overheads, more engineering, more spare performance to keep these things running and running nicely. The other 80% of your apps are the ones where we should be much more aggressive. Give them the performance they really need, with the expectation that the implications of them using it all up are not a big issue, not a huge problem. Having said that, we want to get the real application requirements for that 20%. For my top applications, we need to get those right and not just guesstimate. So we need to be armed and engineered with the correct metrics to put in, because then we know what to guarantee them. It's not just about assigning one metric for performance. There's two that I'm about to talk about. Sorry, there's a question in chat there that I saw. I will answer since I saw it. Are you saying the over provision or under provision is happening in container and K8s? Containers in Kubernetes are almost always over provisioned from performance. And they shouldn't be. Only some should be, the real important ones. When we set the performance for containers, for pods in Kubernetes, there are two main metrics, excluding GPUs for now, but you could argue that's a kind of third one as well. And each metric has kind of two dimensions, a request and a limit. The request is probably the more important one. This is the guarantee. This is Kubernetes saying you will get your requested amount of CPU regardless of the other workloads in the cluster on the same node. The request is also how Kubernetes decides on which worker node to schedule this particular pod, container, application. So the request we need to get right. We need to make sure it's the right size to protect our workloads. The limit, on the other hand, is simply saying if there is free performance on the worker node you are living on, you can scale up to that. You can use the free performance, right? However you might wish. This can be particularly useful on the CPU side if you have pods that use a lot of CPU in startup as they boot up, as they load up, but then drop down. We don't want to set the request to be catering for just a transient spike at the start of the life cycle of the pod. We want that to be closer to the steady state. There is a nuance in between how you should set the CPU limit and the memory limit. It's not the same rule or the same suggestion. There's always an exception to a rule for both. And that's this. The CPU request, you should figure out what the steady state should be. There's a number of ways to do that. The CPU limit, you can set unbounded, have no limit at all, absolutely fine, or you could set it at a very high level. I don't recommend setting the CPU limit artificially low. Just because I have something bursting into the limit, it won't steal resources from other pods. You know, if they've got their requests set right, Kubernetes will make sure they get those. The limit just lets you use surplus performance in the cluster. We can do this because CPU scaling is a regular thing. It's kind of a transient thing. So, you know, my home laptop has had a scaling CPU for 25 years, however long that might be. Multi-cores for 20. Applications are perfectly happy with a CPU that's running 800 megahertz now, 1600 the next. They can move between cores. Some apps you may need to do core pinning or something like that, but that's, again, more to the edge cases. But we're okay with having that CPU limit go up and down. There's no particular impacts from having that. The memory is different. Memory is perfectly happy to go up, but you can't compress it back down. If I need to recover memory from a pod because it's gone past the request and it's on its way to its limit because I set that higher, when I take the memory away, I'm going to kill the pod with an out-of-memory error in Kubernetes. It'll show up as a 137, something like that, which is going to be a kind of unplanned restart of a pod. Now, Kubernetes will handle that. Hopefully your application will handle that, but it's not graceful and it's unnecessary. So I suggest setting the memory request and the limit to be the same. So as memory never has an issue where it surpasses the limit and then has to be killed off because it's taking that memory back to give to some pods that need it to meet their guarantees, their requests. This is a great place to start. There are always edge cases that will move outside of it. So you want to watch the behavior on this point, but this is going to cover the majority of the workloads that you have in a very sensible, very sane way. What I would never do, or really try hard not to do, is set no requests at all. This really just makes it a free-for-all. It's not good for cohabitation, not good for quality of service for your application users. It's just not a structured way to run the cluster. So let's say we've made some changes, there's things going on. How can we help with the complexity of a Kubernetes environment? Because it is. If I start to troubleshoot, if I need to figure out what's going on, I might start looking in Kibana for logs in a certain time window, try and get my search string right. Maybe I'm looking at recent changes in Git for the thing I think is broken, even though I don't know. There's a particular service. Maybe I've got charts in Prometheus. Yeah, I'm tracking down these changes. So I made a little video as a demo. I hope that's okay. We'll run through it together. So imagine you get this Slack message, right? Front end is slow. The website is slow. We think it's wrong with front end running in Kubernetes. We haven't changed front end. Right? So pretend this guy is the application owner. No code changes been made, but suddenly front end is being slow and the website is suffering. So this is that escalation that we don't want. Without some tool, I'm going to show you as the demo. I'm looking in Kibana, open search, looking at charts, investigating changes. What we have to bring order to this chaos is this single view called Cloud Insights, and it's going to take data feeds from across the environment and Kubernetes and bring them into a view where you can look at correlation, causation, give you a timeline of events so we can see what the root cause is of an issue. It doesn't have to be performance. Performance is the topic of today, but this could be anything, a network issues, a failure in some other component, whatever it might be. This is the dashboard where I would start. I can see my kind of high-level metrics of Kubernetes. I'm going to click in and look at the workloads. And front end was the complaint that was made, right, from another team. So I can go and look at front end, see what's going on there. And then straight away, once I click through, I'll see I made no changes. I can see the fault that's being reported. So there is a real problem here. But right now, I don't know what caused it. However, what I can see is there's a related workload. So Cloud Insights has figured out there's another component that is has a relationship with this one. So I can add that to my timeline. And I can see some activity there. So I'm starting to think, okay, maybe I'm tracking down the source of this issue. Let me take a look at a topology map. So I can see the interdependency of these different components in a chart. With the two that I've highlighted kind of front and center, the Insights has suggested to me. So I would look into front end first. Again, this is the one that's been highlighted as having an issue. I can drill in there, look at some more details, see if there's anything obvious. The network latency is high. The round trip time is high. And I can see it's high when it's talking to its partner catalog, right? The catalog service. A whole bunch of retransmits tell me something is very wrong. So I'll go in and look at the catalog. I look at the catalog. I can see in here, yeah, there is a very real alert. And it's CPU throttling in this case. Like, okay, I now know what the problem is. So I can go in, take a look. We're hitting the CPU limit, not the request, the limit. We're maxed out. Kubernetes is now throttling this service. I can fix that. That's great. But I want to understand why it happened. So as I make sure it doesn't happen again. And if I look in the timeline, I can see, well, there was a change, right? The integration with Git is showing me that a deployment was made. I can go and look what was changed. And it was, in this case, conveniently for this presentation, a performance change. The CPU limit was reduced by half. And that CPU limit brought it down under a certain threshold, and that started to cause CPU throttling. Now, because I've got all the components in place, very quickly I can roll that back, adjust that so the way it was, and resolve the issue. So here, in about 3.5 minutes or so, we had a report of an issue over Slack, a very high level one, not a huge amount of detail in there. We drilled in, we saw the errors being brought up, we saw correlation between two components, and then we could see the actual change that was made that caused the issue, and we rolled it back. And that's going to be true for not just for performance, for faults. It could be a storage issue, network, some other kind of failure. It's going to bring in all of the metrics and make that easy for you to see. So that's handling the complexity of an existing environment. It's not actively doing any automation. It's helping you manage what's there. The next section is going to be a little demo of our tools if you want to start driving automation into this. And that'll be using a platform called Ocean. Ocean is sort of software that extends the management of Kubernetes, makes it simpler and easier to manage. It will take care of a lot of the operations complexity for you. It has a bunch of mechanisms in there to control, understand, reduce cost, and it consists with availability. What I'll be looking at today is just specifically the application performance aspect of Ocean and not the rest. And we call that right sizing. It's right sizing at the container level. By its very nature, Ocean is going to right size the Kubernetes instances as well. But this is taking it to the step above. If you like, we right size the pods and containers to the actual workload. Then we right size the instances to the pods and containers. So everything fits nicely down in this little kind of picture that we have here. Imagine the pods, containers, and workloads are the orange boxes, the blue boxes. We make sure those are the right size. Then we make sure they fit very nicely onto the instances. The first approach we take with this is the one we currently have, that we've had for a while, which is a GitOps style approach. The second one I'll show you after, the sort of sneak peek one, is a wholly online kind of automatic, almost a runtime kind of approach, which is pretty neat. But the GitOps style one, so the excellent one today. This one uses Ocean integrated with your Kubernetes cluster, and it uses Spot Connect, which is an integration framework for workflows, low code, no code. The right sizing one is pre-built. You can get this from us, and it's going to integrate with all of the components in your Kubernetes application environment. GitHub, Slack, Kubernetes itself, S3, and so on. The way that our GitOps approach will work is it will get a resource request from here, from Ocean, and it will run that through this workflow. This is Spot Connect, so you can actually build all kinds of things in this workload view. You can connect us up to all these resources you see here. I think there's more now. I already configured this with AWS, Spot, of course, with Slack, and with S3, which are all the components I need for this workflow. You could add more like Jira and things like that if you're going to publish in there. What this workflow will do is it will clone the source code for the application that I have, the manifest file, sorry. It'll clone that repository with the manifests in. It will get the right sizing recommendation from Ocean, and it will update that with a pull request to the cloned repo, and then publish that back out if the pull request is accepted. So here's a manifest file for the app I'm going to play with, a little Nginx application. It doesn't have to be application by application. I might set this workflow up to do a whole bunch at a time. The most important number here is the multiplier at the bottom. This is a safety factor. So I mentioned you kind of top 20% of applications earlier on. You might have that set quite high for your business critical apps, right? You want to play it very safe. You still want to get them sizing correctly, but you want to have a big buffer there for your dev, test, non-production, sandbox kind of stuff. That should be very low. You don't need to reserve a lot of space there. So we'll go through the workflow. We'll run through. It will clone the repo, take the right sizing recommendations from Ocean, publish them to that, generate a pull request, and then issue a Slack message out to alert people that this pull request is ready for review. And we'll run that in just a moment. Of course, you're not looking at this right live. This one's configured with a manual trigger for the sake of my demo. You might have it on a schedule or event-driven. However you might want this to run, you can. It's infinitely customizable. So here it's running through the steps, cloning the repo, getting the right sizing recommendation, publishing that up, creating a pull request, and issuing the Slack message. So once this goes through, don't worry about the pass one. That's if it goes through a different conditional, which is a failure, which this one isn't. Once that's complete, we'll switch over to Slack to see the message arrive. There we go. So that's the one that just happened. I got my pull request. And then as the application owner, I can go in and say, okay, this makes sense to me. You know, I approve. Or I have a good reason. I say, no, okay, I'm not going to accept this. You know, whatever that might be. The sharp-eyed among you, it's very hard to see in this view. The actual request was for 1 millicore and 9 megabytes. Because we had that 3x multiplier as a safety buffer in this particular example, that came through as 3 millicores and 9 megabytes. But you would adjust that to however you might see fit. And it doesn't have to be a multiplier like that. You know, it could be more complicated if you need it to be. So that was the GitOps approach. That's the kind of standard way we do it today. This one that's coming, I find really exciting. What we've seen is a lot of companies moving towards a more online approach, allowing Kubernetes to manipulate the performance of pods as they're launched, maybe through an admission controller, that kind of thing, and allowing them to be different to what's in the manifest, so they can adjust as they need to in place. And this is what we're going to deliver in our sort of second generation, which is coming out in the coming weeks and months. This might be the first place that we've shown it externally. So I hope I shouldn't get into trouble. I have permission. And this is the view that you'll get with this new generation of application right sizing from Spot. Gives you the headline number up the front. You know, you can save $10,000. To me, that's a lot of money. I would certainly act on this. But it's important for you to know that the importance of what you're doing. If it's $1,000 saving and your cloud bill is $1 million a month, maybe not high priority for you. If your cloud bill is 50K a month and you can save 10K here, I'd say that is a big priority. And we're helping you understand where you should be working. This cluster is quite well run on the memory side. Like the memory differential there is, I wouldn't be too worried about that. That's great. The CPU is over allocated by 2x, at least in this example, which would make me a sad bunny. Yeah, I'm paying for that white gap between the light blue or the green and the dark blue line at the top is money that I'm just giving to the hyperscaler. I could click the big blue button and do a kind of quick and easy optimization. That's not what I want to do. I'm going to look at the more advanced setting that we have here. And the way this mechanism works is we're mutating or we're updating the performance rules as the pods are launched. So we're not having to reach out and update the manifest files in the original repo. But what we're doing is setting rules. And these rules will let you manage this at scale. So I might have a production rule for my top 20% of apps, or a critical rule for my top 20%, and a regular production for the rest. I've got an example staging rule here. And the differences will have, you know, the minimum threshold, never scale it down too much. I might have boundaries, so I can scale it only down to a certain amount, up to a certain amount. Production, I maybe only update once a week. Staging, I do 3 times a week. Maybe for dev test, I let it do it as soon as it's available, as shown here. So as the performance changes, the system will issue updated performance guidance and tune that workload inside Kubernetes to adapt as it goes. It might mean it has to move workloads around, but it'll all be taken care of for you. This way, you're going to be able to manage at great scale, thousands of microservices with rules, rather than trying to do it individual workload by workload, which is not scalable at all. So thank you all for your time. I know it was a whole hour, but I don't like super long webcasts. And we'll go through the questions anyway. I saw the little red light flashing up. So we'll see if there's any good ones in there. But my key messages here, over-provisioning, over-engineering, application right-sizing, whatever you want to call it, you should absolutely do it in Kubernetes. Most of the clusters out there, remember the stat at the start from Datadog, they're 2 times as big. And we see this when we onboard customers as well. So everything else can be perfect, but just because of the workload requests, the resource requests, the cluster is twice as provisioned as it needs to be. So the compute cost is twice as much, and the compute cost is normally the main cost in Kubernetes. So set your resource requests for CPUs. CPU limit, you can leave it open or just set it very high. Let it spike and use spare CPU. That's absolutely fine. The memory request and the memory limit should be the same because pods don't like it when memory gets reclaimed. And if you have them the same, you can mostly avoid that, which is going to improve the reliability of your pods. They'll only get reclaimed then when it has to rebalance worker nodes or something like that, which is a much more predictable event. You should use these rules, these suggestions as a starting point, and then monitor with whichever tools you see fit. Monitor and focus your key applications just in case you hit those edge cases. And remember, spend 80% of your engineering time on the top 20% of your applications, the critical ones that get you paid. The second takeaway for me, the fault finding. Kubernetes is complex. We did the demo of the Cloud Insights utility that helps bring clarity to that complexity, gives you correlation and causation. So you can see if something that might at first glance be unrelated is actually the root cause of an issue. The third takeaway, automation. If you're ready to move forward and take this to the next level of automation, then Ocean can come in from us. That plugin to Kubernetes, that's going to bring you either the KitOps approach, where we can integrate with your upstream code and send the resource recommendations up there and manage performance that way. Or when it comes out in sort of the coming weeks, maybe a month or two, the fully automated approach that uses a admission controller and can tune your Kubernetes workload performance on the fly as it goes. So what I'll do now, I think we'll jump to the Q&A. Yeah.
Hey there, Carl. So we've got a lot of questions. So thank you to everyone in our audience for sending those in. Before we jump into those questions, we did launch one of our polls, Carl. So let's go ahead and just take a look at the results here. So this was the question of biggest challenges faced optimizing Kubernetes infrastructure in the cloud. And it looks like our top answer is concern about workload performance, followed by we lack the necessary visibility. And then we've got a tie between busy with higher priority tasks and we don't have the right tools. Does any of this come as a surprise to you, Carl?
No. In fact, it nicely tracks what we had in the other surveys from other sources. So that's good validation. Thank you.
Very nice. Very nice. Awesome. So we do have plenty of questions to run through. And the one thing that you mentioned time and time again was the risks of over provisioning. But are there risks of under provisioning on the flip side?
Absolutely. Absolutely. So we saw that in the example of the Cloud Insights demo was an under provisioned application causing issues, an under provisioned pod, if you like. And that's why it's important to, once you start making these changes, have the monitoring in place so you can detect an issue, but also ideally do it in an educated way. So with metrics from something, could be from Spot Ocean, could be from another tool. There are other ones out there that do the same kind of thing that will give you guidance on where these resource requests should be. For me, the hardest time in the life cycle of an application is when it's brand new and you don't know what these requests should be for things to work. So I would typically err on the caution there, go high. It's going to cost more to start with, but then keep up with the life cycle and bring those resource requests down over time until you understand where they should be for that particular application. So yeah, under resourcing brings pain. So we don't want to do that. That's why we've built this automation and this reporting.
Makes sense. Awesome. So moving straight into our next question, I'll put it up on the screen. What are the biggest challenges you faced to implement your solution, and how do you overcome these challenges?
This seems like an interview question. I'm not looking for another job right now. I like my current job. Biggest challenges. It's a tough question. Typically, it's about getting the acceptance of change. Driving automation, especially for performance, is incredibly sensitive. This normally has the most success if there's a corporate drive behind it, if it's an objective, a key objective, if an executive is saying this has to be done and there's corporate sponsorship on it, and getting people to adopt that automation and kind of go to the next stage, I would say is the biggest challenge. Those that do reap great benefits from it, to be sure.
Great. Thank you, Carl. We'll move right into our question from Faisal. What's the typical organizational cluster size or numbers utilizing Ocean?
There isn't a typical one, and I know because I was messing around in some of the statistics yesterday for another reason. The cluster size for Ocean, I've seen anything from sort of 10 nodes up to hundreds and hundreds. I think there's one there with around 1,000. I'm not sure where the top end is, but it's in use from large-scale enterprises down to a little cloud startup with maybe 2 clusters, 10 nodes in each. You can really start with it at any tier that you may wish.
Wonderful. Our next question is, how do I measure the performance of the tool compared to market standards? What's the resource utilization of this tool compared to market competitors?
I'll start with the second one because I think it's easier. The resource utilization for the tool, if I understand the question right, as in the resources it would use in your cloud environment, is 0. Yeah, both of them are SaaS. So there's no, I guess, infrastructure cost for us. That will be included in the licensing cost. The performance compared to market standards, I don't think there are market standards in this space. There are a handful of companies approaching it at kind of different angles. Some maybe in a more GitOpsy way, some in sort of an online mutating webhook kind of way. Some with sort of an admission controller kind of way. There's a bunch of different approaches to this happening out there, which is why we're trying to deliver choice so you can choose as an organization which one is going to make more sense for you. What I would say is, if you're going to do something, do something in this space. If it's not with us, that's okay. I'll be sad, but don't leave that 2x over provisioning on the table on your cloud bill.
All right, moving straight into a question from Geetha. We've kind of touched on this, but let's dive a little bit deeper. What are the downsides of under-provisioning CPU and memory with the target to increase it as per the usage?
Don't. I'm not saying under-provision at all. I guess I'm saying reduce the over-provisioning. So you want to kind of start trimming it down, but depending on the criticality of the application. If it's not critical, classify it. Say this is not something that needs a whole bunch of engineering time. And if it hits a limit, then it's something, it's not going to cause real issues for anyone. And if that's the case, you can be more aggressive. Maybe take that all the way to the recommendation, whatever tool is giving you recommendations. If it's your critical application, that's where you spend a lot of your time. That's where you provision it slowly, gradually, you bring it down step by step. You look at more metrics. Maybe I do a resource right sizing for a non-critical app and I bring it down all the way to the recommendation, right? Which is maybe a 95th percentile kind of metric. But for my critical application, I only take half of the resource recommendation. I say, look, I'll meet you halfway. So as I give myself a bigger buffer for that. But absolutely, I'm definitely not saying under provision. I'm saying reduce the over provisioning.
Gotcha. No, makes sense. Pinch those pennies where you can.
Yeah, for sure.
So Carl, what's the difference again between GitOps and inline style of application performance automation?
Sure. The GitOps style is going to push basically a change request up to the manifest in the repository for the application. And it's going to update the YAML, update your resource request there, which will then filter back down and come out in the next deployment run. It is, I guess, slower to filter through. it's also kind of taking the changes outside of Kubernetes. What folks are taking now is a more adaptive approach where we don't change the manifest, we don't change the YAML. That gets changed when the pods launch, which enables us to do it more responsively, more flexibly. We have more options about how we might adjust that number as it goes. If it's a replica set, we're running an HPA, I could choose to reload all the pods like a deployment, or I could just choose to launch new pods as it scales up with the new performance settings. So I can do it in a sort of a less disruptive way than if I was doing the GitOps style redeployment. It's essentially more flexible and adaptable. Also, arguably, in terms of who manages the performance, it's putting more control with the folks running the Kubernetes infrastructure than the folks who own the code, depending on how your organization is set up.
Awesome. And does this have an approval system, kind of like GitOps has?
Absolutely. Yeah. So if you're taking the GitOps approach, then you can publish it's a pull request. So someone has to approve that. You can do it without the pull request, but I don't recommend that. That's a fundamental part of that approach, is to have the approval of the owners in there.
All right, so we've got another one here from Lynn. I'll go ahead and maximize it. So scalability is crucial. How can organizations ensure the scalability and optimal performance of their Kubernetes clusters in the cloud, especially as these workloads fluctuate?
That's a big question. Scalability is crucial, absolutely. And it's one of the key aspects of Kubernetes. Ensuring the scalability and optimal performance. So the tools we've seen here will help with that. Having the request set so applications have the appropriate guarantees to continue operating is vital. The request is the guarantee, and it's how Kubernetes lays out everything underneath that. So if the requests are wrong, that will cause you issues down the line. In terms of scalability, there are advanced autoscalers out there. You might use other metrics for scaling. For example, you could use some sort of clever keyless scaling instead of CPU-based scaling. You have your pod scaling and so on. Some things like Ocean, for example, and some other tools have a concept of like headroom, where you can reserve space. So pods will get scheduled straight away, and then we can restore that in the background, so you can scale very quickly. That's a very deep, complex question, I would say. That's probably worth another session in itself.
Yeah, I think we've got a fair amount of questions here that I think really deserve a full deep dive. So maybe we can get you to come back on to address some of these questions. I'll go ahead and pull one since we do have some time here. Is it possible to pull a report on cloud native showback?
Yes, yeah, for sure. We can do that for costs. We could do it for a right sizing report as well. There's all kinds of data can be extracted from the system for you to act upon or just to have as information.
Awesome. Well, Carl, I think we need to start kind of wrapping things up a little bit, but I do want to give you the opportunity to leave us with any closing words or any takeaway. We've ran the key takeaways already, but what do we need to have top of mind as we walk away from this webinar today?
Just go and look and find out just how over provisioned your Kubernetes clusters are. I think kind of the order that folks approach cost optimization for Kubernetes often starts with maybe spot VMs, which of course we love. We're great at that. That's where we came from. Maybe there's some instance right sizing. Maybe you've looked at commitments. Maybe you've looked at Graviton, ARM, x86, and so on. But the real, the hotspot, the big gains are at the moment in this resource request territory. Right, that data was from us. It was from Datadog. It was from the cloud, the CNCF. It was from the FinOps Foundation. It's for sure out there. Kubernetes clusters are almost certainly on the way to being 2 times as big as they need to be. and therefore on the way to being 2 times as expensive as they need to be. So go take a look and figure out if you need to do something, because I'm sure you can make some improvements there. Thank you.
Awesome. Well, Carl, it's been such a pleasure talking with you today. Thank you so much for joining us on Techstrong Learning today and sharing these insights with us.
Thank you all for coming, and thank you for all the questions. I appreciate it.
Of course. And for all the questions that we did not answer today, we are going to forward along over to Carl and the Spot team, so they'll be able to get back with you with a post-webinar email. So once again, thank you so much for all of your questions today. The feedback today was great. Before I release everyone, just a couple of closing remarks. Today's session was recorded, and following this, we will be sending you an email with a link to access the recording on demand. But you can also find it living on the Cloud Native Now website. Just visit cloudnativenow.com/webinars. 2 winners of our $50 Amazon gift card giveaway will be selected here shortly. So thank you for your chats and your questions. I've pinned to the top of the chat a link to our survey, and it's also in the handouts. So please do let us know your feedback today. We would love to hear your thoughts. I'd like to thank Spot by NetApp for sponsoring our program today. And to everyone here, thank you so much for spending your time with us here at Techstrong Learning. We appreciate your time, and we hope to see you at a future learning experience. Have a great rest of your day, and you may now disconnect. Thank you again, Carl.
Thank you.